Hi all, now we're going to tackle, I'm going to introduce you to irrational numbers, then we're going to work on how to perform operations with irrational numbers up until division. All right, so irrational numbers are the positive and negative. Notice there's a positive and negative on the outside, non-perfect squares. So an example of non-perfect squares would be the negative square root of 2, positive square root of 2, square root of 28, negative square root of 35. However, the square root of 28, we can rewrite that as 4 times 7. And now this really is saying the square root of 4 times the square root of 7. And you all know the square root of 4 is 2. So 2 times root 7. So this is still an irrational number because of the root 7, but for irrational numbers that can be reduced, you must reduce them. The other irrational numbers are pi and the letter e. Pi, it's approximate equivalent, the one that you've been working with since about 5th or 6th grade, is about 3.14. And notice those dots mean that decimal number goes on. I think we're at the millionth number of decimal at pi, so that just continues on. And then this letter E is used in exponential and logarithmic equations, and its equivalent is about 2.718. Those are the two common uses of it. Okay, to give you an idea, created this number line, and notice the blue number line, I have 0, 1, 2, 3, 4, 5, 6. So the square root of 1 is 1, the square root of 4 is 2. And if we wanted to figure out the square, well, let's do the square root of 2. Well, the square root of 2 is about there, the square root of 3 is about there. So right about there is the square root of 2, and if you type that into a calculator, square root of 2, you're going to get approximately 1.4. So a number line is a good way if you ever want to know about like the square root of 35, it's really close to the square root of 36. So that might be like a 5.8 or a 5.9 approximation. Okay. Now, when you're adding irrational numbers, you can only add like terms. So I'm going to show you the like terms, addition and subtraction, and the unlike terms. So notice the square root of 3, the square root of 2 plus 3 root 2, the radicals, the number under the radicand, they're the same. So here's that invisible 1. So 1 root 2 plus 3 root 2 is equal to 4 root 2. And for pi, 1 pi plus 3 pi equals 4 pi. If we were to subtract, because they're both, because they are both root 2's, you could perform subtraction. 1 root 2 subtract 3 root 2 is negative 2 root 2. If we were adding or subtracting the e's, 5e plus 2e is equal to 7e. Let's do this over here. So here's the subtraction of pi. 5 pi subtract 2 pi is 3 pi. And then 1e subtract 2e is just negative e, or you could put that invisible 1 on those if you would prefer. So what do you do when the terms are unlike? So now we have root 2 plus root 3. Well, those radicals, those are not the same. They are unlike, so you can't do anything with it. It's root 2 plus root 3. And what about if we added 3 pi plus root 2 plus e? None of those are alike. Now, if you were told to convert, then add, you would get approximation. So 3 times 3.14, because that's an approximation, plus the approximation for root 2 is 1.41, And then the approximation for E is 2.718. Well, now that those are all going to be decimal amounts, you could go ahead and add those because those are now alike. But if you're adding the original numbers, if they're not like terms, they cannot be added together. Okay, multiplication. Root 2 times root 3 is root 6. You can't simplify that further. But notice root 5 times root 10. Well, root 10 we can rewrite as root 5 times root 2. Well, now you've got root 5 times root 5. And if some of you have a difficult time, whenever you multiply two roots together, the radical goes away because they cancel each other out and it just leaves 5. But if you want to think about it this way, root 5 times root 5 is root 25. The square root of 25 is 5. And then so root 5 times root 10 simplifies to 5 root 2. And if you have a distributive, you still distribute both root 3 to both numbers, root 3 times root 6. Well, root 6 can be broken down to root 3 times root 2. And now you have root 3 times root 3. A 3 comes out. And now you have root 3 plus root 2. Root 3 times root 7, those are both prime numbers. So that is not going to simplify. All right, that's it for this one.